What was the first step to graphing this problem? The first step to solving this problem was some variation of solving for y. You could have solved for y. Now this one, you actually probably could have done without doing that simply because, what form is this already in? What form is this equation in? Point-slope form. This is in point-slope form. You have the point 1, -2, -2, 1, and you have a slope of 2. So you could have graphed it like that. But the way I've been showing you to do it was to solve for y. So I'm going to go ahead and solve for y, and then I'm going to let Cameron go up there and graph it. So solving for y, let me get this stuff out of the way. Alright. Here you go. Solving for y, you wanted to, like Gerard said, distribute the 2, add the 1, and you got y equals 2x plus 5, which gives you a slope of 2 and a y-intercept of 5. Did anybody get something other than that when they solved for y? Cameron, do you feel confident in graphing that at this time? Sweet. Let me bring you this BOED. I bet there's a way to extend this BOED, but I don't know how to do it. So screw it. I mean, darn it, we're not going to do it. I mean, because that isn't really a page anymore. This is really a picture of a page that I'm writing over the top of. That's why. Well, you see, when you start writing on these things, it stops being an interactive page, and it's really just a picture that you're drawing on. So that page no longer has those buttons that work. All right, good sir. Knock him dead. It was -2x plus 5. Or wait, positive 2x plus 5.
Okay, you want me to alright. You make little tick marks?
You can. That'd probably be helpful. Man, I have to squint now. I'm so used to straining my eyes to see this thing. Magnificent.
Have you been trying?
Well, no, the smartboard didn't get changed. That's
I know, but could do something to it.
very
It's
possible.
y equals 2x plus 5.
Yes, sir.
Alright.
I doubt it, but I'll try in a second.
Y-intercept would be there. Is it right? The y-intercept?
Your y-intercept is the number without the x.
Oh, so it'd be 5 up.
Yeah, so go up to 5 and what you got. There you go. Now over 2, up 1. No, I'm sorry, rise over 1. Whoa, up 2, over 1.
That's what you just said.
Or
I
it'd
said
be,
over 2, up 1, didn't I?
No.
What?
would it be down 2?
Well, you can do
Well, just remember, is it a positive 2? It doesn't really
Yeah.
matter how you do it as long as in the end it's going up this way. So you can come down over this way or you can go up over that way.
Yeah.
As long as you remember that it's a positive slope, it doesn't really matter how you do it because, yeah, you're kind of out of space going upwards. As long as you remember where it should be going when you're done. Very nice, that'll work. Connect your dots. Very good. Very good. Perfect. Solve for y, plot your y-intercept. That was a problem several people were having yesterday. The number without the x is your intercept. The number with the x is your slope. Okay. Questions on that? Fantastic. Okay, good. Then you can put up your DOMs. We're going to get to today's stoof. Stoof. Yes, it's a flat U. Stuff.
So what?
Put your DOM away. Okay.
My dog has been away.
Now, I have taught you point-slope form and slope-intercept form. I'm going to teach you another way today. Now, doesn't matter, even if I were to teach you 5,000 different equations for a line, it doesn't change the fact that you could always just graph these things by solving for y. Doesn't matter what style you are in, you could always graph them by solving for y, regardless of which style we're in. So, first of all, let's see if, no, see, it's still off. Okay. Today I'm going to teach you about standard form.
What's your line?
What?
What's your line?
What?
He's tried that.
Yeah, I just did. It was off a line. So, standard form, which actually, let me go back for a second. Let me give you an intro page. Standard form is this. AX plus BY equals C. A, B, and C are just going to be numbers. Like 3x plus 5y equals 10, for instance.
Is this Unit 2, Section 2?
Unit 3, Section 2. 3.2. We've had 2 tests. AX plus BY equals C, where A, B, and C will all be numbers. The things that you have to remember about standard form. First of all, order is important. It's going to go X, and then Y, and then C. A, B, and C all have to be whole numbers. You cannot have fractions or decimals for A, B, C. So A, B, and C have to be whole numbers. And A only, has to be positive. A has to be positive. Standard form. The whole purpose of standard form is so that you can always have an equation for a line that looks pretty without some ugly 1/5 or 0.7 or all these negatives. I mean, you're still going to have some negatives, but A itself will be positive. Every single equation in standard... Has everybody got this written down? Who wants it? Every equation in standard form is going to be something like 3x plus 2y equals 6. Or 2x minus 5y equals negative 7. They're all whole numbers. The first one is positive. That's the only one that has to be positive. And yeah, that's going to be standard form. There are going to be times where you get something like negative 4x plus y equals 11. And you're going to think, oh, I'm done. What's wrong with this? The A is negative. So when that happens, you're going to have to multiply the whole thing by negative 1 to make that positive 4x minus y equals negative 11. That would be proper standard form because the A has to be positive. Okay, so let's jump into some examples. All right, examples. Now, I put the first 2 in pink so you can see. All you have to do is put the x's and y's on one side and the number on the other, and then make sure they're all whole numbers and that A is positive. So, let's look at number 7 and how they got that. First thing they had to do was distribute the 4. So they got y minus 5 equals 4x plus 8. Now they had to put the x's on one side and the y's on the other. Now some people, you know what, forget it. I'm just going to do it the way that everybody likes to put the x's and y's on the left. So that's what we're going to do. We're going to move the 4x over to the other side. So that'll be negative 4x plus y minus 5, oh, that's a y, equals 8. What do I have to do now?
What? You break that one? Yeah.
Oh, hold on. That's,
What you do, you add the 5.
yes, all I did was subtract the 4x to the other side. This came over here by subtraction.
Why would you just subtract the, I mean, why don't you just add the 5?
You could have, but okay, you have to remember, the whole point of this is to get them in standard form. We're not solving for y. Now, if I was asking you to graph this, I would. And to be honest, the only reason I'm even teaching you standard form is because there's going to be tests on your problems on your end of course test that require you to know standard form. Whenever in any other class that you're allowed to use whatever form you want, I would never use standard form. But you are going to have to know it, so I'm showing it to you. So that's why we're doing it. Do you? I'm like graphing it and everything? Okay. Well, good. Then you are more than welcome to use it. So add 5 to both sides. And yes, you get negative 4x plus y equals 13. Am I in standard form? Why not? The negative 4. So I have to change everything's sign by multiplying it by negative 1. And that gives you positive 4x minus y equals negative 13, which is where this came from. Positive 4x minus y equals negative 13. Questions? Okay. Now, if you look at 8 and 9, they both have non-whole numbers. And hopefully you'll start to see why, whenever you're doing algebra, fractions are so much better than decimals. We grew up thinking, yeah, but a decimal you can punch it in the calculator. Yes, but When I have a fraction and I need to make everything whole, it's really obvious to see what I need to multiply everything by to get it whole. Just your denominator. I need to multiply all that stuff by 4 so that my fraction will go away. Whereas when you have a decimal, it can be a little fuzzier. Like if it was 2.3, what do you have to multiply that by? Like 10, just move the decimal place. So fractions are preferred here. Just FYI. All right, questions on that one before we look at another one?
We do more fraction.
We're going to do number 8 together, and then I'll let you do number 9 on your own. All right. Number 8. Now, it's up to you when you multiply everything by 4. I like to do it immediately. If I say I'm going to have a fraction, I'm like, hey, let's get rid of that fraction. So I'm thinking, let's multiply everything by 4 so that our fraction will cease to exist. If I multiply everything by 4, I'm going to get 4y plus 12. Well, the 4's are going to cancel here. So that's minus 3. Actually, I don't have to do this any further because undo. Multiplication is a distributive. I was about to multiply both of those. So by multiplying the 4 by this, I've kind of already done it with those two. So I don't actually have to do it by the x and the 1 because I've already done it by something it's being multiplied by. So that would be now x minus 1. And if that's something that you're a little fuzzy on, then by all means, you should just work out the problem without multiplying it by 4 and then multiply it by 4 later, and you'll see what I'm talking about. Okay, so anyway, that's 4y plus 12 equals negative 3x plus 3. Okay? All I did was multiply through by my negative 3. What do I need to do now?
Plus 2. Plus 3.
Plus 3.
Yes.
Plus 3. Or
X. Yes, plus 3x.
2.
What's this 2? This I'm sorry, this should be a 12. Is that what you were talking about? I'm sorry, it's a 12. My bad. So, that's 3x plus 4y plus 12 equals 3. I have to subtract my 12, which would make that negative 9, which is where this comes from. Hey, I have a highlighter. I should use it. Which is where that comes from. Oh, well, now I can't see it. Well, whatever. Now, I can show you pretty quickly how, if you're not confident in the whole, you don't have to multiply the 3/4 by the x and the 1. I mean, obviously you can see the answer is right because it's on the board. But if you're not going to be confident in that, then by all means, don't do the 4 right off the bat. If you're a little fuzzy on what do I multiply by and what do I not, then, does everybody have this who wants it off the board? Then you are more than welcome to just work the problem before multiplying by the 4. So that'd be negative 3/4 x plus 3/4. And then you can multiply it by 4 now and just do it by everything, and you would get the exact same thing.
So if you have a parentheses, like in your equation stuff, and you try to times it all by 4, you don't have to do the parentheses?
Because when we multiplied this by 4, we then took that and multiplied it by both of those, which was then kind of multiplying all those by 4 since that one was. Does that make any sense? Let's look at a more basic example of that. Like, how about this? 6 equals 3 times 1 plus 1, right? Would you agree with that statement? If I was to double both sides, that would be 12 equals 6, but I wouldn't touch this, and it's still a true statement, right? Because that 6 is still going to be distributed throughout. But if you had doubled everything, you'd have gotten 12 equals 6 times 2 plus 2. Is that a true statement? No. So that's why that principle holds true. And that's a tricky one. That's going to take some repetition to get. But again, let's say you're doing your homework and you get to number 8 and you forget that rule. You're like, I don't remember what he said. Make yourself a simple little example that's just like that, like this. And then you can be like, hey, did it work? No. And a lot of times you can lead yourself to the answer by doing that kind of thing.
So you multiply by the denominator?
Yes. Yes, you do. So number 9 Try number 9, and if it would help, I'll tell you that 2.5 is the same as 5 over 2. Try number 9, and I'm going to come around and take a look. I'm going to give you 6 problems today, but there are 3 parts to those problems. I want you to A, put them in standard form like we just did all day. Here's just some more of the same exact thing that we just did. I want you to B, put them in slope-intercept form, and then I want you to graph them, which you'll need slope-intercept to do. So you only have 6, but I want all 3 of these things for all 6 of them. And while you're working on that, I'll call out the academic time stuff.